Alright, what is up everybody? This is Mr. Wilkinen again, and this is a lesson for 3.6. So 3.6 is about one question, I guess. It's a question of what's the distance between a point and a line. So if we looked at this example of what I just circled, if I were to ask you what's the distance between this point and the line, and you had to draw a line from the point to the line, you're probably not going to draw a line like that. Not going to draw a line like that or like that. To get the shortest distance from that point to that line, you have to end up drawing a straight line from that point directly to that line. Alright, and if you notice, that intersection kind of forms a right angle. Remember, when you have lines that are that form a right angle, we call that perpendicular. So to find the distance between a point and a line, you'll have to end up drawing a line that would be perpendicular to that line. So draw a line going through that point to the line that's perpendicular. Alright, so that's what it's asking. To find the distance between the point and the line, you're going to end up drawing a perpendicular line and then finding the distance of that line, or the length. Alright, so the other type of question that you'll get is, and you'll see a couple of these on the homework. On the homework, it'll ask it'll say draw the segment that represents the distance indicated. On your notes you have just 4 triangles like this. I just added the point that we're kind of focusing on and then the line that we're focusing on. If I were to ask you what's the distance between this red point, all of these, what's the distance between the red point and the blue line? The shortest distance from that red to that blue line is not like that or like that. What you might think the shortest distance to get from that point to that line would be if we were to extend that side and make a perpendicular line. That would be the shortest distance. The distance from that point to that side is you actually have to end up extending it all the way out. This is no example of the second one. To get from that point to that line, the line would go on the inside of the triangle. So what you're doing is you're just drawing a straight line from that point, the shortest distance, shortest way to get to that point. And to get from this point to that line, it doesn't look like this line that angle is a right angle. It looks like if we made it here, that would probably be the right angle. Okay, so it's a little bit outside of the shape. Next one, to get from that point to that line, you would have to extend that line like this. Alright, so you just form your right angles. Alright, so that's kind of the first concept to get your mind in the right idea of finding the distance between a point and a line. Next thing, if you were to find the distance between any parallel lines, the easiest way to do that is to just pick out any point on a line, directly across from it will be the distance between those 2 parallel points. If I were to actually find the distance between both of those, the length of both of those line segments I just drew, they'd be the same. Distance between parallel lines is always the same, no matter where you put those points. Alright. Next is an example of the actual question that you'll be tested on, and most of the homework will be on. So what's asking is, using this graph, we have to find the distance from this line, this blue line, to this point that I just circled. Alright? So, there's a few steps to figure this out. The first step they have to do is since we're going to end up making a perpendicular line to this blue line, we have to first figure out the slope of that blue line. Alright? And that's kind of the reason why we did 3.3. That's why we did it. Where it's kind of a brief get us in the mindset of finding slope again. So to find the slope of this line, you could pick out 2 points and then plug in to the slope formula, or you could just pick out 2 points that are kind of formed at an intersection of that graph. So these 2 points are on that line. If I were to find the slope, we go up 3 over 2. So I'm just going to write down the slope of that blue line is 3/2. Alright, so the slope of that blue line is 3/2. That means the slope of the perpendicular line, remember slope of perpendicular lines are negative reciprocals. So to find the negative reciprocal, you flip that fraction and you make it negative. So the slope to get from this point to the line is going to end up being negative 2/3. So what you can do next is you can kind of create that line knowing the slope. If I draw a point there, I go up to, it's negative 2/3, I'm going to go up to back 3 to that point there, and continue on up to back 3 to that point there. Alright, so I drew those points and I make that line. Then that's the line we're dealing with. We're trying to figure out what's the distance of that line that I just drew. There we go. Alright, and the only way you can figure that out, well, you could make a triangle and use Pythagorean theorem, or what you could do is use the distance formula. If you forgot distance formula, we did that in chapter 1. Distance formula, I'll write it down again. x2 minus x1 squared plus y2 minus y1 squared and the square root of all that. Alright, so we have our 2 points. I'll just mark them down. This point is at -1, 2. And then this point is at 5, -2. Alright, so we have our 2 points. We just have to find the distance between them. So I'm going to go x2. x2 I know is negative. X2 is 5. We go 5 minus -1 squared plus y2. y2 I know is -2, and y1 is just a +2. So I'm finding the distance between those. So to simplify that, 5 minus -1 is 6. 6 squared will give us 36. -2 minus 2 is -4. -4 squared, remember, gives us a +16. We get to that, simplify that, and we get 52. Alright, and it's not a perfect square, so I'm going to leave my answer as a square root there. Alright, so that would give you the distance between those 2 points. That tells you the distance between the point and that line. Alright, so to figure these problems out, remember, if it's a problem set up like this, you're going to have to find the slope of that line, find the slope of the perpendicular line, and then using that you can find which point on that line that's given to you will you find the distance between. Alright, so that is it for 3.6. Not too bad, but it's important that we know how to do this. We'll definitely have at least one of these questions on the test, so make sure you know how to do it. If you don't, make sure you reach out, get some help, and we would love to help you out. Alright, thanks for listening. We'll see you later. Peace.